looking at regression analysis. Regression analysis, and in regression analysis, we are going to be examining four major things. That is, number one, we shall be asking ourselves what is the meaning of regression analysis. And number two, we will also be looking at common terms used in regression. What are some of the common terms that are used there in regression? Number three, we are also going to look at the uses of regression. We are going to use check on the uses of regression. Number three, we are going to look at the regression analysis itself, and where we shall be able to tackle even an example so that you can be able to understand very well. So the very first thing we shall start with is the meaning of regression. We are asking ourselves, what is regression? What is regression? And by definition, it is a statistical method that is used to determine the relationship between variables. And the variables are the dependent and independent variable. So when we talk about regression analysis, we are simply talking about that statistical method of determining the relationship between variables, and as I've mentioned, it's the dependent and independent variable. The relationship between the variables and a simple linear regression is obtained through a regression equation that is y is equals to a plus b x. That is our regression equation, and when we will be examining what y is, we shall also be looking at what a signifies when we talk about the regression, and we shall also be knowing what b is when we are talking about regression, and what is the variable x represent in regression analysis. So that is the meaning of regression analysis. When we talk about it, we have said it's a statistical method of determining the relationship between two variables. Number two thing that we are going to examine today is the common terms used in regression analysis. And these are some of terms that are used. Number one term that is used is what we call the variable. The variable is the first term that is used in regression analysis, and we are saying that it is any value or factor. It is any value or factor that can change. So any value or factor that can change is what we are calling variable in regression. It is represented by y here and x in this equation. So these two are what we are calling variable. Why? Because y can change depending on some of the change in x. So that is why we are talking about those two being variable. Number two term that we are going to look at when we talk about regression analysis, it's what we are calling dependent variable. Dependent variable. And every time we talk about dependent variable, we are simply talking about the variable that the researchers wishes to explain, you wish to explain. It's represented by y in this equation. It is represented, this is dependent. The change of y in this equation, it depends in the change of the number of quantities. If they are changed, automatically y also will change. That is why we call it dependent variable. That is why we are calling it dependent variable. For example, if we are talking about the total cost, for example, if we are talking about total cost of a certain commodity, let's say, for example, you want to buy a pen, you want to buy 10 pence. If you want to buy 10 pence, the total cost of 10 pence is dependent on the number of pence. For example, if the pen is costing 100 shillings, that is to say that the total cost of 10 pence will depend on that number, and that is will make it 1,000. And that's why we are calling the dependent variable. Number three term that we are going to examine here when we talk about regression analysis is the independent variable. Independent variable. Independent variable, we are saying, is the value which examines the dependent variable. It examines the dependent variable. So that is to say that it is represented by x in our equation here. It is represented by x in the in this equation. Example is the quantity of units bought. It is the quantity of units bought. This is called the independent variable. So it's a term that we are talking about in regression. And the last term that we are going to examine when we talk about regression analysis is what we call the constant. The constant. It's also known as the coefficient. So that is what we are talking about. It is a variable whose value cannot be changed once assigned value. So it cannot be changed. No wonder we are calling it constant. It is constant. Example, it is the in this equation, our constant here is b here. The b is what denotes our constant. It is something. It is the variable that cannot change, irrespective of the changes in x, the changes in y. B will remain constant. Example we are saying is the unit cost of a product. Unit cost of having explained those terms as we have talked about the terms that are used in regression analysis. We can further say that y is the total cost, whereas that a is the fixed cost, with our b here being the variable cost per unit. And when we are talking about the x is what we are calling the units. And you know that when you talk about the variable cost per unit, when you multiply the two, then they give you the total variable cost. And therefore, we usually say that fixed cost plus the total variable cost is what is giving you the total cost. And I would like to give an illustration. For instance, you want to buy 70 beds, and at the total cost of 500 each, at a total of 500 each, and then we are given the fixed cost, which is 5,000. How can we be able to examine the total cost? How can we be able to examine here the total cost? And this is how you tackle this. So I would like you to follow me clearly, and so that you can very clearly, so that you can see. Therefore, we are examining the total cost, whereby we are having our y, which is equals to, we have talked about the fixed cost, and in our illustration, the fixed cost being 5,000. That is the fixed cost, and I've said that we are examining an illustration here whereby we are saying we are buying 70 bed, and then we are saying the price of every bed is 500, and then number units is 70. So if you multiply the 500 with 70, then you get the total variable cost. Then you add with the 500, and you get the what we are calling the y, which is the total cost. So if you multiply this, it will give you 35,000. It will give you 35,000, and when you add with 5,000, then you get 40,000 as your total cost. I want to believe that we are working together. Now, from there, we are going to examine on the uses of regression analysis. And number one use of regression analysis is estimates the relationship that exists between dependent and independent variable. And as I have mentioned earlier, I've talked about the dependent variable and the independent variable. And that is why we are saying it is regression analysis is used so that we can be able to estimate the relationship between the two variables. Number two, use of regression analysis is that it determines the effect of each independent variable controlling the effect of all other independent variable. That is so evident in multiple regression. So when we talk about that, we are saying that it is another use of regression analysis whereby we are talking about the effect of each independent variable affecting all the other independent variable. Number 3 use of regression analysis: predict the value of dependent variable. It predicts the value of dependent variable. Number 4, another use of regression analysis: to obtain the measure of error in regression line. That is line of best fit. So we can also be able to measure the error using regression analysis. Another use of regression analysis is forecasting. Another one is what we are calling forecasting. This is predicting the future occurrence. We would like to predict the future occurrence. So regression analysis is used in also predicting future occurrence. And the next number is that is time series analysis. This is analyzing the trends of time. You keep on analyzing the trend, how things been moving over a given period of time. Then from there is causal effect. Causal effect is analyzing of what causes the occurrence of the other thing. For instance, when we are talking about causal effect, we can be able to analyze whether overspeeding causes accidents. So that is when we ask ourselves, how many accidents has happened as a result of overspeeding. So that is what we are calling causal effect when we are talking about it being as a use of regression analysis. And I want to believe that you are understanding bit by bit as we move on with our learning today. I also, the next thing that we are supposed to look at while we are looking at regression analysis today is the types of regression analysis. Types of regression analysis. Types of regression analysis. That is another thing that we want to look at today. Types of regression analysis. And I want to believe that every bit is clearly understood. So this is another thing that we want to look at today. And number 1, we are talking about linear regression. Linear regression. Linear regression is the first one. We are saying that this is a straight line relationship. Is a straight line relationship between variables. That is, variables change in the same proportion. So when we have variables which are changing in the same proportion, definitely you understand that this is a linear regression. A linear regression, and it is in the form of y is equals to a plus b x. And I want to believe up to where we are that this equation is not new to you. You can be able to understand because we have looked at the terms and we have been able to explain clearly what each of these denotes. And therefore, we are saying it forms that equation, and the relationship between in linear regression takes this kind of a form. If you are to represent it in a graph whereby you have y and this becomes your x, then it takes a form of a straight line in that manner. So when we talk about linear regression, that is the form in which it takes. So number 2 type of regression is what we call nonlinear. Nonlinear. So nonlinear regression. So nonlinear regression. So nonlinear, we are saying it implies have relationship. That is where we find things like logarithmic relationship, whereby we are talking about non-linear. Non-linear. We have number 3 type of regression, which is simple. It is called simple regression. It contains only one independent variable. So it contains what? We are saying that if a regression be simple, it contains only one independent variable. And I want to believe that you are understanding when I mention independent variable. It is one of the terms. Remember, we have talked about the terms that are used in regression analysis, and we are saying that simple regression contains only one independent variable. Then number 4 is multiple regression. And multiple regression, it contains more than one independent variable. It contains more than one. So when I talk about simple, we are talking about containing of one independent variable. But when we talk about multiple now, multiple, it says it is whereby it contains more than one independent variable. So I want to believe that we are very, very okay up to that point. I want to look to some details, something about simple linear regression. That is what we want to look at, and we examine and look at an example there where we shall be able to understand further when we talk about regression analysis. So I want to look at simple linear regression. So we are looking at this. We are saying that it consists one independent variable, which is x. It contains one independent variable, which is x. The relationship between x and y is described by a linear function. And I want to believe I have talked about it all. It is also called the regression equation. So the linear function, whereby we are talking about y is equals to a plus bx. For them that are keen following, we understand very well this function. Change in y is assumed to be caused by change in x. So when we talk about the linear function in this equation, we are saying that any change that might occur in y, it is caused by any change of x. That is why we are calling it that. And when we talk about it, can be positive. This relationship can be positive. So if it be positive, this is how we are going to represent it in a graph. This is, if it is positive, this becomes your y, this becomes your x. And if it is positive, it takes this form. That is a positive relationship. In simple linear regression, we are saying it can be positive, it can be presented this way. If it be negative, if it's be a negative relationship, if this relationship can occur and it be negative, then a negative relationship now, negative one, it takes this form. It takes this form. So you can be easily know where when the relationship is negative or positive. So that is the form it takes. And also, it can also be another way whereby there is no relationship that exists between the variables. If that there is no relationship, then also I want you to note this is how it can be also be denoted, where there is no relationship, no relationship. So we can have it as this way. So this also denotes that there is no relationship. So I have talked about simple linear regression, and I've said that it takes the form of y is equals to a plus bx. It's something that I've been able to explain in details, and I'm telling and saying that it can take three forms, and I've been able to explain whereby we have a positive relationship, and also where it have a negative relationship, and where there is no relationship. So those are the three forms in which it can be able to take. I want to actually tackle an example, an illustration, so that you can understand, you can get to see on some of the realities that we are talking about here. And this is the illustration I would like us to look at, whereby we are given the value of two variables. So we have our illustration whereby we have x and we also have y, and the value of x is 0, 1, 2, 3, 4. We are having that, and also we have the values of y, 2, 3, therefore we also have 5, and then 4 and 6. So given that, you need to evaluate, or you are supposed to look at what we have also always been talking about, the x is equals to a plus bx. Don't forget that that is our regression function, and we want to tackle that. You cannot be able to examine any regression equation not having using a normal equation. We have been given a normal equation, and you only need to cram. You can only need to cram this, whereby we have which we say is given by the summation of y minus b summation of x. Then you divide all this by n. So that is how you get your a. And for you to get your b, therefore you need to have b is also equals to n summation of y, and then you minus the summation of x into bracket summation of y. That is how you obtain that, divided by n summation of x squared minus what we are saying is the summation of x into bracket squared. So this is the normal equation, how you can easily obtain the value of a and obtain the value of b. And if you are given this kind of an illustration, you can be able to check clearly that there are things you can be able to obtain from the illustration according to the normal equation. And these are some of the things that I want us to come up with. Number one, we need to come up with x, y. And we can start by having the summation. Summation simply say it means the ANDing of the values that you are given in x. So if we AND the values of x, we get the summation of x, whereby you are having 10. If we have to get the summation of y, this now becomes summation of y, then also is you end up this, and they will end up to 20. The other one we need to look at is x, y, where you take your x, you multiply. You keep multiply and you have the value. You take that and multiply, you have your value, and then also you can be able to get the summation there. So this becomes 0, and this becomes 3, whereby we also have 10, we also have 12, and then also we have 24. If you have the summation of x, y, then you are supposed to AND, and then definitely you are going to have 49. So the other column, the other value that we need to look at is from our so-called equation here, normal equation. We must evaluate the value of x squared. X squared, we need to have x squared. And x squared, you just square the values of x. We have 0, and then we have 1, we have 4, and then we have 9, and then we have 16. So if you have the summation of x squared, then you are going to have 30. And then the last thing that you are going to have is the summation of what we are saying, the summation of y squared, and you also square the values of y, where we have 4, and then we have 9, and then also we have 25, then 16, and then you also have 36, which you obtain the summation of y squared is 90. So with having done that, you only need to substitute. You only now need to come to your formula and substitute these values. So we start with obtaining the value of b, because b is used to calculate the value of a. So definitely you need to start with to get the value of b, and b, you need to come here and say b is equals to, you substitute from what you have been able to calculate. You need only to come and fill these figures for you to calculate. And now n, I need to tell you what n is. N is the number of these values. So if you have to have our n, we need to have 1, 2, 3, 4, 5. So n is equals to 5 is the number. So we are having 5, and then multiplied by the summation of y, which is the summation of x. This should be the summation of xy. It should be the summation of xy, sorry. So when we talk about the summation of xy here, we have 49. So you come here and fill with 49. That is how it should be. Then you minus, as you just go as the formula state, summation of x, which is 10. So you have your 10, and then we have summation of y, which is 20. So you have that, and then you divide by what? You divide by n. Remember, we have said n is 5 into bracket summation of x squared. X squared is 30. So you come and pick your 30, and then you minus the summation of what? X. Then it is squared. Summation of x here, which is 10, and then it's squared. So by solving this question, you will be having what we are saying is 245, then you minus 200, you divide by what we are saying is 150, and then you minus 100, and this we are talking about the value of b. So this will definitely be 45 divided by 50, and you definitely you are going to get 0.9. So when we are looking at the value of b, b is equals to 0.9. That is the value of b. So I want to believe that up to that extent you have understood clearly the value of b. You note that the value of b is what we are calling 0.9, and therefore we can be able now to look at the value of a. We can be able to calculate now the value of a now that we have a b. So it will be very easy. I want to believe that you have been able to look at that and understood. Therefore, we need to look at the value of a. The value of a, very simple. We need to replace x summation of y, which we are obtaining it here. We are saying it's 20, and then we minus. Remember b we have said it is 0.9. Then you multiply with the summation of x, which is 10. That is summation of x, and then you divide by your n. And I've said that n is the number. N is the number, which is 5. So If you do that, what you are going to obtain is that this should be 11, this 20 minus 9, you obtain 11 over 5, this is your A, and therefore your value for A will be 2.2. Don't forget that the value of B, so you have your A, and then the value of B is 0.9. Therefore, if you are looking at the regression equation, that is y is equals to a plus bx, definitely you have the value of a and you have the value of b. Therefore, your linear function will be y is equals to a, which is 2.2 plus 0.9x. So this will be your linear function. In various questions, you can be asked if you determine the value of y, or the total value of y given x to be a certain figure. So having this equation, if you are told to determine the value of y given x to be 5, to be 10, you only need to come to your linear function, and where there is x, you replace, and then you calculate, you get the value of y comfortably. So I want to believe that that if you want, for instance, you are told to calculate, you get the value of x or of y if you are told x is equals to is something like 7. What do you need to do? So you only need to come to your equation and you say y is equals to what? It is equals to 2.2, and then you plus 0.9 into bracket 7. So you calculate. So you are going to take 0.9 multiplied by 7. 0.9 you multiply by 7, and then after multiplying you add. After multiplication you add. So if you have to finish that, you have y is equals to 2.2 plus 6.3. Therefore your y should be 8. Your y should be 8.5. So that is how you obtain that. Definitely, that is how you are going to solve that kind of a question. And I want to believe that you have really understood what regression analysis is. Here is Achievers College of Professionals EMBU, and we get to you wherever you are. We learn and understand. If you need to join us, register online. We are providing all the classes and materials that you need to understand. This was a class of statistics, regression analysis. Until my name is Julius Karani Monene, so a teacher in statistics. Until next time, always in Achievers College of Professionals EBU. We raise manpower.